The following is a co-production of and is jointly funded by the Weather Channel and the National Oceanic and Atmospheric Administration.
Creeping along the ground, dashing up the trunks of trees, leaping from treetop to treetop.
Fire is a very interesting critter.
Every move that a wildfire makes is crucial to the firefighters who risk their lives to battle the blaze. And firefighters know that there's one overriding factor that will determine how easy or tough their job will be: the weather. While crews on the ground and planes in the air work around the clock building fire breaks and dousing flames, meteorologists are making critical predictions to ensure that the firefighters who go into the fire make it out.
There's the very real possibility that some of those eyes you look into in the morning shift briefing, if you make the wrong call, they might not be there the next morning.
Coming up, meet the elite group of fire weather specialists assigned to play a life and death role on the firefighting team. See how the forces of nature can generate tornado-like fire behavior, and find out what it takes to forecast the Inferno. A gust of wind, a rise in temperature, a drop in humidity. These changes in the weather might have little effect on our daily lives, but during a wildfire, they can mean trouble. When unexpected weather changes cause a wildfire to shift directions or become more intense, the consequences can be devastating. Perhaps nobody knows this better than Bob Salee. At 17, he was trained to be a smoke jumper for the U.S. Forest Service, one of the firefighters who parachutes onto the scene of a wildfire. He had no idea that on his very first jump, he would face one of the most infamous firefighting tragedies in U.S. history. A small fire was burning in Man Gulch, a steep valley in the northern Rockies. Bob was one of 15 smoke jumpers sent in to put it out on a very hot, very dry day in 1949.
When we got there, the fire was about 30 or 40 acres burning along the top of the ridge. You could see flames in a few places, but mostly it was just smoke. It didn't look like it was going to be a very tough situation at all.
But without warning, a change in the weather turned a fire that was manageable into a monster. Historians have speculated that a thunderstorm passed over and the updrafts that it generated sent the fire roaring into the gulch. Bob and his team were suddenly facing an enormous and deafening fire.
The fire was probably 50 or 75 yards behind us. It was coming really fast.
With the fire racing toward them, Bob and his friend, Walt Rumsey, desperately looked for a way out. In the smoke and the chaos, somehow they stumbled upon a path which led them up the gulch.
When I got to the top, there was a lot of smoke and a lot of heat, and I wasn't sure whether I was going to make it or not.
But amazingly, Bob and Walt survived. 12 smoke jumpers and a forest ranger were not so fortunate.
I guess we were just the luckiest people alive that day, and the other fellows ran out of luck.
The Man Gulch incident remains one of the most notorious fire weather disasters. But deadly shifts in the weather are still surprising fire crews today. Arizona, June 26, 1990. Firefighters battling the so-called Dude Fire were shocked by unexpected winds. The strong winds sent fire spreading rapidly in all directions. 6 firefighters were fatally trapped in its flames. 4 years later in Colorado, sudden strong gusts struck again, killing 14 firefighters on the South Canyon fire. There was no chance for escape when 200-foot flames blew straight for them. These are the stories that wildland firefighters think of with dread. They show just what can happen when you don't know what the weather around a fire is going to do.
Weather is a key component to fire spread, and the firefighters on the ground are obviously concerned about what the fire is going to do in any particular time.
So today, when a wildfire breaks out, even the most experienced firefighters won't make a move without consulting a key member of their team, the Incident Meteorologist, or IMET. IMETs are the National Weather Service specialists who are the on-the-ground weather experts for firefighters. There are only 63 of them in the country. The IMETs are there because the fire crews don't want to find themselves in the path of a fire while they're trying to fight it.
They're there to watch out for the safety of the crew.
When wildland firefighters are called into action, an IMET is assigned to join them at the fire camp. The IMET sets up a small weather office on the scene and will be on call 24 hours a day as the fire rages. Passing on forecasts to the firefighting team so they can plan their attack.
While it's cool and moist under that.
When the IMETs get up in front of the group to give weather briefings, everyone pays attention.
There's the very real possibility that some of those eyes you look into in the morning shift briefing, if you make the wrong call, they might not be there the next morning.
With lives on the line and time working against them, IMETs have to make some grueling decisions that can mean the ultimate success or failure of a firefighting mission.
The job is a lot like what I would liken to a place kicker on a football team. There are certain times when you have to come out and do exactly what it is you're trained to do and do it exactly right because the game is on the line.
IMET John Saltenberger speaks from experience. He had to step up when he was called to Washington State in 1991. The city of Spokane was surrounded by wildfire.
On the approach into the Spokane airport that evening, I remember looking out the window of the aircraft and seeing fires all over.
Northeastern Washington was under siege by a violent windstorm. 62-mile-per-hour wind gusts had sent an astonishing 92 fires raging into several neighborhoods. More than 100 homes were left in ashes, and one woman died trying to outrun the flames. The community was devastated and terrified by the thought of even more destruction. But to everyone's relief, the winds soon calmed down, and the fires calmed down too. Mark Labhart was the incident commander in charge of the firefighting team.
We were starting to get a handle on the fire. I was starting to feel a lot better until John came up to me and said, "Mark, I need to talk to you."
It was very bad news. John was predicting another windstorm, just as ferocious as the first one.
I think my heart just sank at that point in time.
The winds, if they came as forecasted, would certainly mean new dramatic flare-ups in the fire.
The potential for a major catastrophe was in the making.
At the time, it was only my second year as an incident meteorologist. I didn't want them to think that this was just some rookie crying wolf in the wind. I wanted them to take quite seriously the information that I had.
We were literally making million-dollar decisions on a forecast that was from a person that was fairly new.
But Mark was convinced that John's forecast was right on. He contacted the governor, who declared a state of emergency and authorized the fire team to rush in dozens of extra crews. They would be in position to protect homes if the fires got bad again. And then, everyone waited.
My stomach was turning. I slept very little.
If the winds actually materialized, it was time and money well spent. If the winds didn't materialize as forecasted, then they would look rather foolish.
It was a risk, you bet.
At first, nothing happened. But then, as John had predicted, the winds started picking up, and soon intense fires were being stirred up again by an all-out windstorm. This time, with the extra crews in place, not one more life or home was lost. And John, the rookie incident meteorologist who made the conclusive forecast, was a hero.
There was a lot of high fives for John. There was a lot of pats on the back for John.
When you're able to forecast those things and they take action on it, everybody looks good.
In response to a recent surge in catastrophic wildfires, the National Weather Service, part of the National Oceanic and Atmospheric Administration, has doubled the number of incident meteorologists on staff. IMETs are also trained to go to the scene of other incidents that could need on-site weather information, oil spills, search and rescue missions, or terrorist attacks. Up next.
It's not just the incident meteorologist that's out there on a forest fire, it's the entire National Weather Service.
See how the IMETs are supported by teams of forecasters across the country.
3, 2, 1, launch!
And assisted by some high-flying and far-reaching tools of the trade. When a wildfire breaks out, an incident meteorologist crunches data to come up with the forecasts that will be used to answer some pressing questions. Where can the fire crews safely position themselves? And how long can they be in place?
You'll see a forecast for the general public that seems like a really nice day.
Light winds to start the day out of the south, but the winds will pick up and even change direction as the frontal boundary moves on through.
It seems like a great day, you know, let's go to the beach, but your fire could be burning in one direction at 1 minute, and as soon as that front passes, you got the fire burning in another direction.
Predicting fire weather can be a tricky business, and it requires a lot of training. Each year, all the incident meteorologists gather for a week at the National Interagency Fire Center in Boise, Idaho. It's a chance to compare notes, for the new IMETs to learn from the veterans, and for everyone to practice with some key fire weather equipment, like the pie ball.
A pie ball is a pilot balloon. Pilot balloon. That's how it goes, yeah.
The pie ball is a helium-filled balloon that's launched to track the winds up in the atmosphere.
Winds are pretty much the most important thing to be concerned about on fires. And when we're out on fires, we launch these a couple times during the day, you know, once in the morning at least and in the afternoon.
Using an instrument called a theodolite, IMETs measure the angle of the path that the balloon takes.
62 degrees.
Then they calculate the wind's speed and direction.
As it goes up, we see where the stronger winds are, where the light winds are.
3, 2, ready? Launch!
On a fire, although the IMET is the only weather specialist on the scene, he or she is not working alone.
It's not just the incident meteorologist that's out there on a forest fire, it's the entire National Weather Service.
As firefighters rely on the IMETs in the field, the IMETs rely on their counterparts at National Weather Service forecast offices around the country. The local forecast offices keep in contact with the IMETs on fires in their specific regions. Forecast office meteorologists watch for threatening signs like increasing winds, high temperatures, or very low humidities. And when they see trouble, they issue a so-called red flag warning. That lets the fire teams know to expect explosive fire growth. Backing up the local forecast offices, there are meteorologists tracking fire weather on a national scale.
This is the Storm Prediction Center in Norman, Oklahoma.
Meteorologists at the Storm Prediction Center give national firefighting agencies advanced warning of where fires are likely to get started, so the agencies can determine where in the country firefighters will be needed most.
This map is showing fire danger ratings on a scale of 1 to 5. 5 correlates to an extreme fire danger.
The biggest priority here during the fire season is to be on the lookout for those great fire starters in the sky. Dry thunderstorms.
All it takes is one lightning strike to ignite a fire. In the west, quite commonly, there's a deep, dry layer of air beneath the thunderstorm, and so a lot of the rain that does occur with those thunderstorms evaporates before it gets to the ground.
The answer? Cloud-to-ground lightning detectors. These devices can pick up magnetic waves from lightning within a 100-mile radius. Using these readings, forecasters at the Storm Prediction Center can track a storm almost strike by strike. Their reports are posted on the web and can be instantly accessed by anyone, even an incident meteorologist at a fire in the middle of nowhere.
We have a little satellite dish that we take and set up in our laptop computer. We also have model equations that we can look at, the mathematical interpretations of what the atmosphere might be doing.
Without this equipment, we'd be in a pickle out there in the field.
In fact, sometimes the most important piece of firefighting equipment at the scene of a fire isn't an axe or a helicopter. It's the satellite dish, bringing weather information to the IMET. IMET Jim Wallman can tell you that. When he was dispatched to the Pine Fire near Lebec, California in 2004, his satellite data and forecasts soon became the focal point of the firefighting operation.
When I had arrived, the fire had pretty much consumed most of the hillside and had threatened quite a few homes.
To tame the fire, firefighters wanted to set a burnout, a deliberate fire that would burn the vegetation above the main fire before it turned that way. They needed to know from Jim when the wind conditions were just right to light it. It was a tense moment. If the burnout was lit at the wrong time, the fire could have raged out of control.
If the wind came in the opposite direction and you lit the fire, then it would have actually made the situation that much worse.
When he was confident, Jim gave the go-ahead forecast, and the fire crew went ahead with the burnout. Thankfully, the forecast was accurate, and the burnout was a complete success.
It was a big relief, a lot of smiles.
What could have been a major tragedy had been averted. Up next, see how extreme fire weather can prompt some amazing fire behavior.
They look like hundreds and thousands of fireflies coming through the air.
Any lightning strikes?
Meteorologists make predictions about what the weather in and around a wildfire is going to do. But that information alone is not enough. Firefighters need to know how the fire will react when the weather changes. How is the speed, direction, or intensity of the fire going to change? Enter the fire behavior analysts. Armed with computer modeling software, they pick up where the weather experts leave off.
Using the weather information provided from the Weather Service, we calculate what we expect the fire behavior to do.
Predicting fire weather or fire behavior is not an exact science, and even the experts are often awestruck by what a fire can do.
Fire is a very interesting critter in that it can surprise you even when you think you know everything. You have good tools to predict what it's going to do. Sometimes it will surprise you in what its capability is.
A fire can become so large and intense that it can actually generate its own local weather. The winds it creates can propel smoke, embers, and ash as high as 5 miles into the sky. As incredible a sight as that is, this one is even rarer and more awe-inspiring. The fire whirl, a tornado of fire.
Fire whirl results from instability and wind that starts spinning around in a clockwise direction. And as it spins, it sucks more and more air in at the base of the whirl.
These fiery whirlwinds can be as small as a dust devil or as big as a small tornado. A small fire whirl might be 50 feet high. A big one could extend 500 feet into the air with winds of 100 miles per hour.
Depending on the size of the whirl, the intensity of the fire, it's not uncommon to see, large pieces of sagebrush, branches from trees that are laying on the ground, those types of things be picked up and lofted through the air as a result of that intensity.
Fire whirls are definitely a sign of dangerous fire weather. Another bad sign, spotting. That's when very strong winds take embers from the main fire and send them flying through the air, where they can land on dry materials and start new fires.
You notice it more at night than you do in the daytime, but as it starts to get dark, the embers flying through the air, they look like fireflies, hundreds and thousands of fireflies, or a sparkler, the 4th of July.
It's possible for these sparks to travel a mile or more from the main fire.
I'm somewhat amazed at how fire evolves and spreads.
When extreme fire weather causes fire whirls and severe spotting, the best fire crews can do is to get out of the way fast. Once again, it's the fire weather forecasters to the rescue, alerting firefighters when these fascinating but deadly fire phenomena are likely to develop. Coming up,
we're taking a look at how we can make things better, faster.
Forecasting the future of fire weather. See what innovations are on the horizon that can make tracking the weather around a fire more precise and relevant. Wildfires can move fast, so fire weather forecasters have to keep up. In forecasting fire weather, both the small scope and the big picture are vital. And meteorologists hope to improve their predictions of both. On a small scale, right now, the computer programs that IMETs work with in the field are limited. They produce forecasts for the area around a fire, but the IMETs have to use their knowledge and experience to guess how the features of the landscape might change that forecast. But in the future, they hope to be able to create forecasts that take into account things like nearby canyons or ridges.
Research is going on every day into making finer and finer scaled weather models and weather prediction software.
Looking at the big picture, researchers are working to improve climate forecasts, with better predictions of when things like severe drought or the El Niño phenomenon can be expected. Fire agencies will know when a bad fire season is coming so they can be ready for it.
We do pretty well out to 5 or 10 days. It would be really nice to say, this week in August, 3 months from now, it's going to be like this. Well, that would be phenomenal.
As fire weather forecasting gets better and better, wildland fires will become more predictable. That means firefighters will be safer, and more lives and homes will be protected.
This has been a co-production of and is jointly funded by the Weather Channel and the National Oceanic and Atmospheric Administration.